Correct pronunciation. All right, we've just started, and in this video or lesson, we're going to go through two things. We're going to go through Eulers' method, and we're also going to go through slope fields. For the record, slope fields was in a short answer in 2006 and maybe 7. And the problem is that all the examiners said this is a waste of students' time. We can assess it in multiple choice, basically. And I'm going to show you all of the exam questions in the last 8 years for both Eulers' method and for slope fields. So get in the context, the reason why we spend so long on differential equations, setting them up, solving them, type 1, 2, 3, is for the exact reason is that 20 to 25 marks out of 100, 25% of your exam will relate to differential equations, which are not Eulers' method and slope fields. Okay, so that's why I've spent more time on those, and that's why I will spend more time on those even. So let's have a look at the formula sheet. When you go to the formula sheet, and I don't know, okay, all right, let's have a look at the formula sheet. When you go to the formula sheet, we've done a lot of messing around there. The formula sheet doesn't tell you everything, because remember when we were differentiating and anti-differentiating, there was actually that we had some rules. When anti-differentiating, we also had substitution, trig identities, partial fractions, polynomial division, that sort of thing. It certainly isn't the be-all, end-all. However, Eulers' method is on the formula sheet, but the problem is that it's a little bit confusing. It says if dy dx equals f of x. So what it actually means is that like the derivative at a point is f of x. Okay? It says x of naught equals a, y of naught equals b, then x to the n plus 1 is equal to x to the n plus h. In other words, we're going up in step sizes of what size? Of h. Good. And y to the n plus 1, okay, y to the n plus 1, in other words, each time we go up one little step, whatever we decide that step is, then we're actually giving a generalised solution to a differential equation, but it's an approximation. Does that make sense so far? Now what we're going to do then is we're going to recall this, and I'm going to get my, I don't know how I'm going to do it. Maybe if I go to the start menu and go snipping tool, but I don't know how I can do that without typing. So I might just go over here, and I might just go like this, and I might just do a little snip of that. Snip, snip. Okay. Enthralling viewing. It is enthralling viewing. And what we're then going to do is we want to do this one, and I'm going to snip, snip, and place it, and I'm going to place it, what do we do? Rotate, order, send to the front. So that way I can drag it up here. I can't do it.
Yeah, so we need to change the formatting.
Oh, that sucks.
So right-click it?
Right-click it. Okay. You know what I'm going to do? I'm going to pause the video so people don't have to bother with this. Now. All right, so what we're going to say is, and how I would set this out, is what we're doing is we're using Eulers' method to find y2. So we've got to find y1 first. Now, y0 is where you start. So we've actually got to do two steps of Eulers' method. Does that make sense? Always start at y0, okay? But the thing is that if you start, you usually are given y0, because what is y0? y0 equals 1. The step size, the first step, so is going to go to 1.1, okay? And then the next step is going to go, oh, actually, y of 0 equals y of 1. So what's x? What's x? X naught. What's x naught?
1.
Thank you. Okay. Now, so what we've got to do is, I guess we've got to write down what we know first. Like, as in, you don't need to do this in an exam. You do not need to do this in an exam. All right. But this is what I would do personally, and because I know Eulers' formula. I'm going to say that y1 is approximately equal to, according to the formula, y0 plus my step size, which I haven't written yet, over, and be careful, like 0.1, I want to sort of avoid those sort of things. I want to avoid fractions and decimals. So I'm going to put, like, is it 1 over... Now, x is what? x0, which is 1? Yes, it is. Okay, 1 over x0 if you like. Now, that is approximately equal to y0 is, let's get something now, but be careful, you've got to use the approximation sign because this is just an approximation. All right? If omitting the approximation sign could potentially, I'm not sure, I haven't had to mark anything with Eulers' method that's not in multiple choice, so, but do the approximation sign. That's equal to 1 plus, now h is 1 over 10, isn't it? 1 over? 1 over 1, brilliant. Which is approximately equal to, or we can say that's equal to, well, let's just say approximately equal to 11 over 10. Would you agree with that? Yep. Okay, good. Now, what you've done is you now need to use the previous step, which is y1. Because that's like n, it's going up in ones. y1, y2, x1, x2, right? So now what we have to do is y2 is approximately equal to y1 plus h of 1 over what? x1, thank you. Now, we found what x1 is and all of that business. So y2 is approximately equal to y1, which is 11 over 10, plus what? 1 on 10 times what? 1.1? So 1 over? 11 over 10, Nikita. That's correct, yes. Good. 1 over 11 over 10. And if your algebra... Now what you would then realise, that's approximately equal to 10 on 11. The 10s are going to cancel out, isn't it? Going to be 11 over 10 plus 1 on 11. Are we okay with that? Now, all right, now, we've got a simple... What if... We've got 11, we've got 10, we're adding two fractions. We don't have a calculator because this is an exam 1 question. By the way, what year was this? 2007. Now we're going to show you the next time Eulers' method was in a short answer. It's not going to be that regularly, but we're probably due for it. And to be honest, if we are due for it, then you should be happy that it's a Eulers' method question, Eulers' method. So what we do is that the common denominator is when only if you multiply both 10 and 11 together. So I have to multiply 10 by 11, 110. So that is equal to 110. 11 times 11 is 121, is it not? And of course, that's plus 10, isn't it? Which is equal to 131 over 10. Of course, sorry, over 110. Are we okay with that? Express your answer as a fraction. Okay, now let's sort of have a look. Now, it says solve a differential equation, but I am going to pause the video now, and we're going to go to the 2007 exam 1 to sort of see what students do and do wrong. Because, now I'm going to resume that because this question, 38% of students got 0. 55% of students, 65% of students got 0 or 1. Only, well, it's interesting that because 36, maybe they did some rounding or whatever, because I'm not sure if 65 plus 36 adds to 100. Not quite. But anyway, they might have done a bit of rounding or whatever. But do you think that was that hard? Does it make sense? But let's have a look at what students did wrong. many students were able to start this question, but some had very little idea of how to apply the given rule. And that's because they look at the formula sheet and they don't know what they're doing. The formula sheet says let f of x equal to y dx. Isn't that confusing? Yeah? You need to know what the formula means. If you try to rote learn formulas and things, then you're just wasting your time. Typical errors in the application of Eulers' method included that y1 is equal to y0 plus h dash x of 1. What's the problem with that?
It's not x1.
Sorry? It's not x1, it's x. It's x0. Yeah, or x0. Good. And to be honest, that's where most students, and also then quite a few of the students started very well, were unable to complete the question successfully, often due to fraction errors, because you don't have a calculator. You know, 110 and 110, you had to get a common denominator of 110, and you had to do that in your head because you didn't have a calculator. And you had to multiply in your head your 11 times tables, and you also had to do 10 times, 10 times 1, which is 10. Yeah? That one's easy. Yeah? But what can you see there? Shh. Do you think you might have had problems if you started with decimals? Good. So look at the question in your reading time. Look at the question and go, and just give yourself a mental note. When I do that question, I'm going to change that 0.1 to 1 over 10. Are we okay with that so far? All right, very good. So what we're going to then do is go, I'm going to just, have I paused it? All right. We're still recording, aren't we? Okay. Now, good. Shh. Now, let's solve the differential equation given in part A to find the value of y, which is estimated by y2. What are we doing here, ladies and gentlemen? What differential equation do we have? What were we told? What were we told? dy dx, we've got to solve a differential equation for such as dy dx is equal to 1 on x. Okay, so therefore what does y equal? What does y equal? Okay, good. The antiderivative of 1 on x dx, okay, which is equal to log e to the x, and you can write log ln if you like, that's fine. I probably should write ln. But what about when x equals 1, what does y equal?
1.
Y is equal to 1. Okay, so therefore we've got, so let's sub that into our equation. We've got 1 is equal to log e to the 1 plus c, but log to the base e to the 1 is what? 0. So therefore we can say c is equal to? 1. Everyone is a 0. Oh, 0. Okay, so therefore we can say that we've solved a differential equation, and this is just a type 1 differential equation, and therefore we can say that y is equal to log e to the base of x plus 1, but the problem is, have we answered the question? No, what is it saying?
It says estimated by y2.
Okay, so what we have to do is that when y2 is when x is equal to what?
1.
Well done.
Good job, team.
Good. Now I guarantee you, now this is only worth 2 marks. So look, doing this was worth 1 mark. Like if you get to this, I would imagine that would be your first mark. But a lot of students would have got that. And if you didn't, well, you shouldn't have been in the course, for sure, right?
Yeah.
But there are some students that slip through the cracks and they do it anyway. But when x equals y, sorry, what we're going to say is, don't we want y2? So therefore, y2 is equal to what? Log e 1.2 plus 1. And really great students like Nikita will then put a box around it, make it easy, because that way the examiner goes tick, tick, and you get your 2 marks. Okay? Now, by the way, that was worth 4 marks out of the 2007 exam 1. How many percent is that? 10% was on Eulers, well, not really, Eulers method, which does relate to differential equations.
Did you say 10%?
4 marks out of 40, exam 1.
It's okay.
No calculator. Now I'm going to pause that there. Now, first of all, I'm just going to say that in the same exam, in exam 1, they had a slope field question in the short answer, and I'm going to show you that in future exams, then pretty much it's just in multiple choice. Okay, it's like usually 1 mark in multiple choice, so 1 mark out of 80. So if you decided, do I want to learn differential equations, or if I didn't have time, do I want to learn slope fields? Then you go, well, I'll just learn differential equations, because then that's 25% of my exams. This is going to be 1 mark out of 80. What's 1 mark out of 80 as a percentage? Not much. Okay, but anyway, I'm going to go through it. When y equals 1, what does dy dx equal? We're just going to pick some values. What is it? 2 on 2? Which is 1, isn't it? Yes? Okay. So, when y equals 1, what can you tell me about the slopes?
The slopes are 1.
The slopes are 1. Now, what does that mean? What does a slope of 1 mean?
It's got a gradient of 1 in that point.
Exactly. It means that it goes across 1 and up 1, yeah? Would you agree? Would you agree that this is a slope field?
Yep.
Does that look pretty much right? Okay. Now, what's going to happen as my slope gets incredibly high?
2.
Let's do y equals 2. What's going to happen? dy dx
5 on 2.
is equal to 5 on 2. Now, 5 on 2 is 2.5 times 1, isn't it? Now, the thing is, what do you notice? It means that every time you go across 2, you'd go up 5, wouldn't you? Now, we can't even do that. But what we do know is that our slope is going to be pretty high, isn't it? It's pretty hard to actually do that, though, because, like, if I go from 3 to... If I go across 2, it's going to go up 5. How do I do that? Like, maybe I could start... What would you do?
Just make it look steep.
Make it look pretty steep, yeah?
Yeah. Just pretty much go vertical. But not really.
Pretty... Are we okay with that?
Yeah.
How stupid is it? How dumb is it? All right, because what a waste of time. We can assess you in other ways. Now, we're going to keep going because this question's only worth 2 bloody marks, right? What can you tell me, though, at y equals 0? Isn't it a half? So isn't that mean the slope is going to be like, oh, that's even too much. Is that, but you know what, I'd get the marks for that because they know that it's just ridiculous. Now, what about y equals -1 because it's squared?
It's just the same.
It's the same as 1, isn't it? So dumb.
And so that's it.
That's right. That's what you got to do. Because but the thing is, you've got to do it for all of this. Look how many lines you have to draw. What a dumb question. They're assessing whether you can draw a line.
Oh, you hate 3 marks.
Yeah, but the thing is, it was a waste of time because the thing is that this is supposed to take you 3 minutes, and well, we're gonna show you. I bet you no way. No, seriously. You think that people at last year, every student would go, oh, can you tell me about slope fields because I've forgotten everything about it. But that's okay. But I'm going to go through them anyway, and you can watch this video rather than you come up to me. You'll watch this video again, and you'll get it. All right, I'm not even going to finish it. Okay, you get the idea, yes? All right, now I'm going to pause it because we're going to go to the 2007. All right, now just just letting you know that that question that you claim was really easy, a bunch of lines, was 53% of students got 0 marks. Yeah, exactly, you don't get it. Well, that's the thing, is because a lot of people that year, that's when slope fields, I think, was introduced maybe the year before and had never really been assessed. And the problem is that a lot of teachers didn't know how to teach it. And also, as well, is there was just so many problems for little mistakes. Let's have a look. And this is why you do need to read, not just let me read examiners' reports. I'd like you just to have a read of that now. I'm going to pause the video, of course, though, because it's just a waste of YouTube time. Yeah.
Does that ask you to actually draw the proper graph too? Or is that
No. Oh, yes. Does it ask? I don't think it does.
Yeah,
Or
it
it
does.
does.
C, it does.
Sketch the slope field of this. Well,
C, in C it does.
okay.
Yeah, it doesn't ask yet. Can we please just do it one at a time?
Yes. All right. Shh. All right. Thank you. All right. Shh. Okay. Shh. Let's have a look at part B then. I'm just going to show you how I did it. It says here, if y is equal to -1, and I'm going to zoom in a little bit. If y is equal to -1 when x equals 0, solve the differential equation. Okay? So what I'm going to just flip straight away. dx dy is equal to 2 on 1 plus y squared. Are you okay with that? Okay, so therefore x is equal to 2 outside of 1 over 1 plus y squared dy. Are we following me so far? Now, my formula sheet should tell me that that is equal to 2 inverse tan of y. And if you have to look at your formula sheet to recognise that, then you're not a very good specialist maths student, because you would have memorised that. I know it was a little while ago. Now, x is equal to 0, y is equal to -1. Now, c is equal to -2 tan of -1. Now, this is the problem. See this thing here, that was done really poorly, but that implies that. It means that you've skipped a step, but that's not a key step because they know that you've done year 7 maths. Okay? So that's what I want you to start doing. Skipping steps that aren't... Now, what we're going to say then is that Therefore, I'm going to just skip a step because I got to work that out in my head to be pi on 2, is that right? C's pi on 2?
Yeah.
Good. All right, so what we can say is so x is equal to 2 inverse tan of y plus pi on 2. What was that for? Okay, Now, remember though, it's saying if we're solving a differential equation, what does that mean? Of y, don't we? So what we're going to do is we're going to do that, and remember that the inverse can be, reversed, if that makes sense. So what we're going to say is that we've got x minus pi on 2 is equal to 2 inverse tan. Now you probably should use a uppercase T. That's not a problem. And then what we're saying is that therefore y is equal to, I'm going to divide both sides by 2, and I'm going to therefore skip a step, and this is not an essential step because they know that you know what you're doing. Y is equal to tan x on 2 minus pi on 4. Okay, we're happy with that? All right, good. So now let's have a look. That was worth 3 marks. A lot of students would have struggled with that, but it's straight off the formula. All right, would you agree that was done not too bad by students? They either knew how to do it or they didn't. 46% of students getting 3, but I thought that was pretty easy, yeah? Okay. Now the thing is that we've solved that differential equation which we've got, and we've used the slope field for it. But what does the tan graph look like? This is the thing. It's then asking us. And now what you notice with a slope field is a slope field will give you an approximation, and you can do slope fields on your calculator. Ooh, how? Okay. I believe I can fly. All right, now. Touch the sky and all that sort of stuff. But guess what? I can't show you that yet because you don't have a calculator for this exam, do you?
You've got the singing voice for YouTube, so.
Oh, thanks, mate. I have the voice of a combination of Fergie and Jesus. Do you know where that's from? Step Brothers.
Yes.
You have the voice of an angel. It's like a combination of Fergie and Jesus. Anyway.
It's going to go viral.
All right. Okay. So, well, it won't really go viral. Now, the thing is that a tan graph should pretty much look like this. And the thing is that you get these values from the step sizes. Okay, so that's basically you can actually follow that trend, and you're given initial conditions. Okay. You should be given that when x equals, I think they give it to you here. Look, when x equals 0, y equals -1. So you know that the thing is that we know if it's actually going to go through all of these points, but the thing is that we know it's this one because of that initial condition they've told you. Do you understand that? Very good. Okay, it doesn't have to be a perfect drawing, by the way. And I bet you that was, look at that. Have a look at that. Now, sounded like my bronchitis.
I felt sick in the throat.
Students found this question difficult. The majority of students who correctly expressed y in terms of x, part B, were unable to sketch it, blah, 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 yada, yada, yada. Okay, now, I'm going to keep going. And this time, we've done that one. Oh, Eulers method, 2013. By the way, it's no longer, it's just a multiple choice question. Go ahead and do that now, please. And you've got a CAS calculator, but the problem is, have a look at these values. They're so incredibly close together, you have to do it extremely well in your calculator. So I'm going to pause this video now. Shh. Luke Rezick is going to now explain the calculator thingy-majingy, but I never really got to, or you could spend a lesson on this, but he's going to explain it to you now. So go, Luke.
Alright, so essentially you go to the book function here, which gives you all your references, and then you go down to E, and then you'll find something that literally just is called, if you go down low enough, something that's just called Euler, which is right here.
Well done.
Gives you the instructions, but just random letters to me, so
Beautiful.
I do not care. So the first thing you do is you write down your derivative function. So in this example we had 1/3 plus 3x plus x squared. So that's the first thing you put into the bracket. So, whoops, wrong function. So fraction 1. So 3 plus 3x.
You should be writing this in your calculator, by the way. And you should be writing what he's doing and the instructions in red pen in your sheet.
So much like the differential equations, we write down the two variables that we care about. So x, which is at the bottom, and then comma y, which is also at the bottom. Then you do another comma, and this is where you put in the gradient, or the domain in which you're doing the Eulers method for. So you go control, and then you push the domain button, which is over the right open bracket, I think. Oh no, sorry, over the right over bracket. So it'll get you those two brackets, of course. So what you want to do is you want to write down the initial value of x, which is specified to be 0 here. And then you put a comma to say what the next value is going to be. And because it's saying it wants the value of y2, then we know that the second value of x will be when the second value of x that we care about will be x2. So x2, with the step size being 0.1, would be 0.2.
Oh, sorry, 0.2.
Yeah. x1 would be 0.1, so x2 would be 0.2.
Yeah.
So we go to the next one, and we put a comma. Then this is where we put the initial value of y, which in this case is 1. Alright, and then we put another comma, and then this is where we put the step size. So in this case, the step size is 0.1. And then we push enter, and then it should tell us what our answers are. And your answer should be the one in the bottom right corner.
Wow. Can everyone give Luke a big round of applause? Luke, that is absolutely brilliant. You would make a great teacher, but rather than me, I want you to be a university lecturer or whatever. You know what? Do the UMAT and become the world's greatest surgeon. Well done. All right. Okay. Don't be a teacher like me because I drive around in a really terrible car. Okay. Now, can I just say this though? You need to be a robot when doing this. You do need to be a robot when doing this. And if you can't just watch that once, you're going to have to understand that. And guess what? It's on the video. It will be on there. Okay. Now, the thing is, though, and this is the last thing I'll say today because I know that we're sort of aware of the time, the only other way of doing this is doing it in your calculator in 2 steps. Okay, so once again, though, I'm a bit old school at times and I know how to do it on the calculator, but sometimes for me, only because I guess, sometimes my head works like a calculator, is actually doing it twice and actually calculating and doing the rounding myself. Okay, but can I just say that, Luke, your method is better than mine, what I would do. But the problem is that you have to be so careful with what you're putting in the calculator. Because if you put the wrong thing in the calculator isn't that smart to say, sorry, you put in the wrong thing. Okay, so I'm going to stop the video there, and I know that goes for 32 minutes, but I hope that you have learnt enough about Eulers' method and slope fields, Eulers' method. Now, what I am going to do is a part 2 where I go through all of the multiple choice slope field questions and explain to you how you do not use the calculator for those because you're wasting your time. Okay? But I will show you how to use the calculator so that way you can get that understanding if you wish. Or if you have time, you can check your solution or your answer by putting it in your calculator. Okay? All right, so thanks again. Thank you, Luke, for that brilliant insight. I personally didn't know that function. There was another function that we used to do that's in the Essentials book, which is like creating an algorithm and stuff, and it's a waste of time. Thank you, well done.